discussing the chapter polynomials. Okay, so why we will study this thing? What is the motivation behind this? So let us see. So first of all, we will try to introduce some basic concepts that in mathematics there are some symbols which will be used like these things x, y, z. These will be used to denote variables, and this 2x, 3x, minus x, minus half x, these are all algebraic expressions, and in algebraic expressions are of the form a constant into x. So in general we write or we express constants as a, b, c, etc. by these letters. Okay, so what is the basic difference of a constant and a variable? So basic difference of a constant means if it is decided once in a problem, it won't change its value. Okay, and what is variable? Variable is a symbol which is used to denote several values of something with respect to the problem. So which is used to denote several values of something. Okay, so as for example, if we take variable x can take any real value, or x can take any integer value. It will depend upon the context. Okay, but if we take a as a constant in some problem, a won't change its value. Whatever value we will think about a, that will be fixed forever for that particular problem. Okay, right. So what is about the main concepts here? So why we will study those polynomial thing? Let us see. In the first figure, that is figure 2.1, we are looking, we can see that. Okay, so we can see that we are determining perimeter of a square, right? So how can we determine? If the length of each side is 3 units, then the perimeter will be 4 into 3, right? And if it is 10 units, then the perimeter will be 40 units, right? So if we vary the length of the square, length of each side of a square, then we can get perimeter as 4x unit. We can vary x as a length of side of a square, right? So we can get perimeter by 4x unit. Similarly, if we can vary x as the length of a side of a square, we can get x square as its area, right? So we are getting the things that 4x as perimeter. In our real life expression, we are getting x square as area, right? So in our real life expressions, there are various applications of polynomials in our life. So what the polynomial is? So we will going to basically define the polynomial. So let us see what is a polynomial. Definition of a polynomial in one variable. Polynomial in one variable. Okay, so it is one variable. So here our variable is only one, that is x. We are not going to take several variables like x, y, z, etc., etc. We are not going to consider this thing a priori. Later, we will see some examples of several variable polynomials also. Okay, so what is the polynomial in one variable? So it is basically an algebraic expression. We know various kind of algebraic expressions, right? So a particular form of algebraic expression which is of the form a naught plus a1x plus plus an x to the power n. Keep it in mind, an will always not equals to 0. Here x is variable and a0, a1, an will be constant. Okay, so these constants a0, a1, an are called coefficients of a polynomial. Okay, so the definition is clear. Okay, so let us see here that each term of a polynomial, here in this book it is taken as this example, as an example of a polynomial. So we can see that the coefficient of x cube is -1, the coefficient of x square is +4, the coefficient of x is 7, and -2 is the coefficient of x to the power 0, that is constant term with no variable. Okay, so here is another important notion of zero polynomial, that is that the constant polynomial. Okay, another one is constant polynomial. So a constant polynomial is an algebraic expression with no variable. So as for example here, 2, -5, 7, 9, 13, -222, etc., etc. These are examples of constant polynomials. If the constant polynomial is 0, then we say it's a special name, that is zero polynomial. Okay, zero polynomial. Okay, so there are several examples of polynomials we have seen, right? But there are also non-polynomials. Okay, there are also non-polynomials but they are algebraic expressions. How can we understand that one is a polynomial and which algebraic expression is not a polynomial? So this is the question, right? So let us see. As for example, here, as in this example, they are taking root x plus 3. So see here, this x, the power of x is half, which is not a integer, right? Not a natural number or 0, right? So another example, So this cannot be a polynomial. So another example, because in the definition of our polynomial, that is a0 plus a1x plus dot 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 plus an x to the power n, all the powers of x will be, that is 1, 2 up to n or 0. Okay, so here it can't be a polynomial, that root x plus 3. If we take x plus 1 over x, here also it can be written as x plus x to the power minus 1. So here x to the power minus 1 is present, so it can be a polynomial as well. Okay, so these are not the examples of a polynomial. Okay, so in the next video we will discuss about the degree of the polynomial. Okay, all right.